So a warm welcome to all the participants. We were waiting for a few of the participants to join. That's why this delay. So once again, I request whoever joins, they can mute their audio and video and then join. So we have 50 joined. We had received almost 90 confirmations in this event. So hopefully the other 40 will be joining soon and will be with us. Once again, I would like to welcome all of you to this AICTE sponsored short-term training program on IoT powered solutions for healthcare innovations. In fact, really happy to see that many are interested in this interdisciplinary field. And we had proposed this STTP, finding that during this COVID pandemic, this is one field where all of us in the engineering background has to work towards to, that is applying our engineering concepts for healthcare innovations. Before going on to the session, I would like to express my heartfelt gratitude to AICTE member secretary and to the AICTE faculty development cell director for approving this short-term training program. Without their approval, this event is not possible. In addition to that, I would like to express my heartfelt gratitude to the management, our CEO, Dr. Anand Jacob Vargas, and our director, Dr. Annie Jacob Vargas, for their full-fledged support for organizing this short-term training program. To tell a few words about this event is considered to be, we need to conduct it in 4 series. This is the first series of the event, which is based on IoT. The second series will be conducted from December 25th to December 30th. And this will be on AI for healthcare innovations. And we have another 2 series coming up in the month of January. So during January, we have both based on a research perspective. So we have 4 series, and this is the first series of out of the 4 series. I would also like to thank and express my gratitude to our principal sir, Dr. G. Prabhakaran, and to Associate Dean Madam, Dr. P. Devasundari, for supporting us in conducting this event. I also take this opportunity to thank all the head of departments and the faculty and the co-coordinators who have been working for 1 month to make this event possible. Now, after this, let us go to the some of the rules of this event. As per the AICTE norms, they have requested us to give the certificates to the faculty who has 80% of attendance, and also they have asked us to conduct one exam during the end of the course, that is during the 6th day of the course, and that will be conducted on Saturday, December 5th around 4 p.m. So you will have to have a minimum pass mark, and the marks and the names will be sent to AICTE for approval, and then your certificates will be issued. So this is the rules for the course. And thanks for joining. We have people are joining, and I would also request the participants to join with their ID. So as we had mentioned in the mail, the format of your login name should be STTP ID underscore the full name of your full name as per the name you have entered in the registration forms. So can we go to the first session? Yes, I hope all of you are waiting for the first session. Let me introduce the first speaker of our session, Dr. Ramya S. Murthy. She is the she is founder and director of NIMAYA Robotics Private Limited. She is a DST Inspire Fellow as well as an IIS Fellow. She has done her doctorate in robotics with the specialization in social robotics. She has designed various products based on IoT for training the special privileged children, and that is why we had chosen for her for this inaugural talk, so that we will have a bit overview of how this IoT is being applied for specific applications. So Dr. Ramya has designed various products to train children with autism syndrome disorder and with various other multiple disabilities. We welcome you, ma'am, for this session. We are indeed privileged to have such a renowned person for the inaugural session. We welcome you, ma'am.
Thank you so much. Thank you so much for having me. It's a great opportunity. I'm really honored to be here.
So
So,
over to you.
thank you.
Thank you, ma'am. Thank you.
Sure. I hope everybody can see me and hear me clearly. If somebody could give me a
Yes, ma'am.
phone.
Yes.
Oh, perfect.
Yes.
So I know since due to COVID, we've not been having any kind of in-person sessions, and that is something that I would definitely prefer over online. But this is our new normal right now. So there are a couple of things that I would just say ahead. In case if there's there any kind of discrepancies or you're not able to see what I'm sharing or you're not able to hear me, please interject immediately. And if you have any doubts as part of the presentation, do put it in the chat box. I'll try to answer it then and there. If not, of course, we have a query session at the end of the presentation. And I'm looking forward to interacting with all of you. I really hope all of you are in the best spirits today. And we will go ahead with the presentation. I'm going to share it here now. Can everybody see the presentation?
Yes.
All right, perfect. So, once again, so we kind of all know how the technology has been improving and how we've been moving forward, right? Futuristic technology is all that is about right now. What do we see is that IoT is like the big trend and the big thing right now. And let's see how IoT fits in. I'm sure all of us have had this kind of a situation where we've always thought, oh my God, if I had known if this was going to happen, I would have avoided it somehow. Or there would have been situations, something would have gone wrong majorly, and then we would be like, I don't know what went wrong, but it has gone wrong. So imagine just for a single person to think so much, it is a lot of work. Now extrapolate it to an entire industry floor where there's like 200 different machines working and there are probably 2000 different employees. But imagine if there's going to be several different systems failing at the same time or in various systems. Do you think even if you have enough resources, you will be able to figure out what is happening when? I don't know how many people have seen this movie called Minority Report, where they tend to get the futuristic applications and then they tend to stop crime even before it happened. If you guys have seen it, I'm sure you'll be able to relate to it. What if I tell you that is possible? That is what you see in the future. And IoT makes that possible. So that's what you're here to discuss. And that's exactly why it's called To Infinity and Beyond, because the thinking it just goes way beyond it. The limit is not there. So that is very much possible. But how is this going to be possible? Before that, let me give you a quick intro of who I am. Hi, I am Dr. Ramaz Murthy. Ipa ma'am, thank you so much for that wonderful introduction. So we develop mechatronic and robotic systems to enhance daily life activities of children with autism and other multiple disabilities. And let's go on with the presentation and you will get to know more about what IoT is and what we do as part of IoT as well. So like I told you, it's the next big thing. You know, we want data, we want IoT. Everybody comes up and asks, oh, we do IoT applications. We want IoT applications to be involved. But how many people do you think actually understand the importance and the complexities that goes into it? So let's go to the very basic of it. One second. Just a second. Hello?
Hello.
Yeah, can you see it?
Yes, the presentation is visible.
Okay. So what is IoT? Right? IoT is nothing but, just like everybody says, it's Internet of Things. So what does that mean? It is a thing-to-thing connectivity. Let me explain what thing is later on. Let me just give you a basic of what it is. It's a thing-to-thing connectivity, as in one device or few systems are connected together over a communication medium to another device. So this is what is called Internet of Things. So why is Internet coming? The other device on the other side or the communication is predominantly the Internet. So it is just the basis of communication of everything over a wireless connection or an Internet base. So what is it used for? It can be used in any kind of application, healthcare, education, automotive industries, anywhere that is required, regular housing. And most importantly, these need not be just one device connected to a system to a protocol, but it can be several different devices in different combinations connected to it. Right? All right. All right. So when a customer comes to you, what do they ask you for? You know, what is the first thing that we go ask a vegetable vendor? I don't know how many people are Tamil. I'm just going to say, "Anna koncham korachu potu kudunga." So basically, that means reduce the price. That's pretty much in probably in any language. That's what we'll do with a vegetable vendor, right? So that's exactly what a customer is going to ask you. They're going to ask you for you to reduce the cost of their running, their operations, or their industry floor. Deepa ma'am, there is some serious distortion I'm getting. Can everybody go on mute?
It is, I think, due to the messages posted in the chat box. I will
No, I
request the
may.
participants to kindly post the messages and queries after the session.
Perfect. I'm able to hear crows, so I thought it was somebody's mic was on. Okay. So that's the first thing they're going to ask you. They're going to ask you, please reduce the cost for us, right? And the next thing, please increase the efficiency. Everything has to work perfectly. Everything has to work at the right time, all of it. Most importantly, they want to collect the data that you can see. Why are we collecting data and how all of this is going to be done? So what helps in building you the solution? First, you need to sense and measure the parameters. Whatever the parameters that the device is going to give you, you need to measure it. Collect all of them, put it together to a centralized location. Later on, you can work with the different data, you can analyze it, you can figure it out and get an output and finally take a decision based on the output or the results that you get. So, what do we do right now and what is that we can do using IoT? What we do right now is we use PLC, we use SCADA, we use different kind of robots, CNC machines, all of that as part of the industry floor. So I'm just going to predominantly take an industry floor so that it gives us a wider example to talk about. So imagine there is an assembly line where there are several different robots, right, working for different applications. For example, say take a car assembly line, right? So there's one robot that's going to do spot welding, one going to put a screws in the jig, and there is several things that's going to open and close the door. So there are several different robots doing different applications. Imagine all of a sudden you realize the third robo alone keeps failing every 3 days or 4 days. We are not able to find out why. What will be our usual go-to process? We'll have a person who will be waiting for it. The mechanic, he'll go check the robot. He'll figure out what is going wrong, why it is going wrong, why it is shutting down. Sometimes you really can't figure out why it is shutting down or the actual period as to why it is shutting down. So that's when you realize, okay, how do we get it? Imagine if you can get a data over a period of time. So say you keep collecting data from all the 7 different systems, 7 different robots, and then see, this is the third robot alone fails, probably the man can figure it out. But imagine in that 7 different robots, or when there are 200 different robots, the 75th robot goes off, and then the third one fails, and then all of a sudden the 100th one fails. It can be any way possible. You can't keep deploying a person to each of those robots to figure it out, right? So imagine you keep getting data from all of them. You kind of tend to understand how the learning curve is, what is happening, how is the operation curve, how is it going to work, and what is failing. That is exactly what IoT does. It takes continuous data and time measurements. And then now getting the time measurements, you kind of figure out you can prevent it even before the problem happens. How can you do this? When you get the data, you analyze the data. For example, say the third robot that I was talking about keeps failing on the third day. You don't understand why. Or what happens is then later on you figure out the robo keeps running for 3 hours together, and the third hard cap, the robo shuts down. So there could be several different methods, I mean, reasons as to why this is happening, right? One, maybe it is overheating. That could be a huge possibility, right? And then, or there is some kind of a jig or some kind of a material that the robot is fitting in that does not work. Maybe it does not have the necessary gripper to fit it in the exact position, or it needs extra calibration. Anything could be the possibility. So imagine you are able to actually figure out what the possibilities are. Now, over a period of time, you get the data and you analyze it, and you see the third robo alone keeps failing after a 3-hour gap. Now, what do? You kind of get to it, see that it is overheating, and then you'll be able to run the robo for 2 hours and reorder the entire assembly line according to that robo. That's one solution. The other one will be probably take off that robo and replace it with something else that is much more efficient or much more that's needed for the system. But now see what all you end up saving through this whole thing. You don't have to spend too much on setting a person every time the system fails. You are able to save on the assembly line time. Imagine the production keeps stopping every 3 hours. What all you could save up. So you end up saving cost, you end up saving time, which is again pretty much cost. So you can save so much on expenses, you can save so many different things just by getting the data and analyzing them. And that's what IoT makes super easy for you to do. So the IoT reference architecture is what you see on the screen right now. So as you can see, I'm sure it's all visible for everybody. As you can see on the right side, we have the sensors, things, gateway. You can see the different examples. So it could be probably, it could be a camera, or it could be from a flight. For example, let me give you a quick example of a case study that always happens right now. I'm sure everybody's heard of General Electricals, who basically provide engines to the planes. They no longer sell the engine simply because they rent it out for every airlines possible. Every 2-3 months, they keep changing the engine. You know why? Because they actually observe more than 2,000 different parameters that comes as part of the engine. This helps them to keep track of how the engine works, how the efficiency is, because it's going to be a metal tube with so many kilometers high. So imagine something goes wrong and you end up figuring it out after the engine fails. So this way, they are able to keep track of all the parameters that happens, and they're able to prevent it even before the accident or anything happens. Imagine the amount of life that is being saved because of that one single IoT application. So we've got the sensor things in the gateway here. The internet is probably the medium that it communicates to the cloud application. So here on the left side, we have the cloud application with different servers. For the different applications on the right side, we'll have different servers that's required. And then the users and the monitoring is what the output application that you see on. I'll explain all of this way more in the further. Right. So let's go to the basic IoT application. Most of the time, okay, now what you see as T1, T2 are the things that I was talking to you about. Most of the time, these things are the ones that is already contained in the client's location, right? So those are the devices that the client wants to monitor. So those will be the thing. And then we've got a gateway. So what is a gateway? That's the most important part of the IoT. You know why? You've had the cloud service given by somebody. You've got your devices. You need to monitor, but then you need to see it in the cloud or in a local server. How do you do it? There has to be a communication device or a communication medium here which will convert those data or communicate those data to your cloud. Here the ISP is the internet service provider. It could be right now for us what I'm sure everybody's aware of Pathway, Airtel, and all of that, right? Coming to the thing here, this could be communicated to the gateway either with a local transfer or via wide area network. It does not matter. But for it to go to a cloud, you definitely need the internet. So each of these things gives different parameters. This is the different arrows that you can see. Then goes through the gateway, gets communicated over the internet to the cloud. Right? And most of the times, the things can use a non-IP protocol. That is a non-internet-based protocol, like Bluetooth, or it could be a long-range network or anything. And then these put together can connect through a IP protocol and then get to the cloud. Just like development of any other device, we end up with a ton of challenges even when it's IoT because it's a developing side. So what is the issues that we see? First thing, for you to monitor the devices over a period of time or over the whole day or 24/7, you need low power circuits. Right? If you're going to have high power circuits, it's going to overheat and pretty much end up leading to a failure. So your circuits have to be designed perfectly for the range. That way, you can use an IoT application with it. And the second problem is that it could be a non-IP that is connecting to a local network, but then for that to go to an internet, you definitely need an internet connectivity. That is where exactly how I explained it to you before. Gateway is a very, very, very important factor in it. Here comes the gateway's problem. The gateway has to be customized for every different application. You can't use what you're using for a car manufacturing company to a healthcare. Right? Depending on the device or the things that is on one side, you will have to keep changing your gateway. So there's quite a lot of design that has to get into developing the gateway. Now, the important part is just like how a few minutes before I couldn't log on to my to the meeting today because my internet connection just went to honky. So if that's going to happen, if you're going to right now, I think most of us are in Chennai or from different areas. We had a cyclone situation some time ago, and pretty much most of the network was down. That's the case, you're not going to get the data through. So public network or a GSM or an Ethernet or any of the internet connection is an absolute must. These are the challenges that you get. Not everywhere you have internet, right? There are a few shortcomings as well, which is something that we could work on. Like I told you, complex gateways. For every little development, a different set of technology has to be introduced. It has to be a different type of architecture. It has to have the capacity to transfer the particular set of parameters. For example, say in case of a car robo, we will probably keep the track of how long the robo is running, if the robo is doing the job right or wrong, is it going back to the home position, is the gripper in the right place when it's all done, is it the number of times that robo is doing the job. In case of healthcare, that's not what is going to happen. For every person, you will be figuring out, for example, how you take a full body test, right? It could be BP, it could be, temperature, it could be anything. So the parameters are not the same. So the output or the parameters that you get is not going to be the exact same thing that you can use a similar gateway to put it to the cloud. So that is where your design comes in. Next important thing is I'm going to quickly show you the block diagram previously. So here you can see if this gray area, that is the internet, goes off, say for example, in the thing side, there is a fire happening, and then your internet goes off. You are on the cloud side. Say your factory is in Bangalore and I am here in Chennai. Now I have no idea what has happened here because you don't have an internet connection. Another biggest challenge that you will come to see is that the response time is a bit of an issue. For example, by the time it reaches the gateway, say it's locally stores, and then by the time it reaches the cloud, you won't be able to reach out to the fire immediately. It is going to take that bit of a time or a delay within which anything can happen. But these are shortcomings which can actually be worked on with multiple other ways. Another most important thing is when it comes to area like ours, what happens is we do have a ton of data. Again, data is the next big thing. So we have a ton of data that gets stored. Now, security becomes a problem. Imagine somebody has access to your local server or to your internet or to any of where you're storing it, then there is a possibility of the compromise. So that is something we have to be very ready about. And this is something that we need to know, figure a way out to fix it, and then get into application of the IoT. So what makes a very solid, robust IoT solution? Every IoT solution has sensors. The sensors are for the parameter measurement. Of course, if the sensor is going to be a part of it, then you need electronics, and then you'll have a communication medium. Then you have to have a cloud infrastructure where you're going to store. And then in the cloud infrastructure, you're going to have different kinds of applications, which is going to help you work with it. Those are the technologies. So the devices that comes as part of the technology is, like I told you, things, gateways, service providers, clouds, and application. So now we are going to go deep into what a thing is, what a gateway is, and all of it. But before that, I would like to take my own device as a case study, right? That will give you a better understanding of how it works. So For that, you need to know the origin story of how NIMAYA robotics started. How did I first get into this field? Is actually, I would call it God's calling because I meant to do this, but it was a bit of a rush. So what happened was after my MTech, I did my MTech in robotics, and then when I was applying to different colleges for PhD, I realized that I ran into a lot of people from an autism background. Could be a mother, could be a son, could be a principal of a special school. So that is when I first got to know what autism was. And then I went to their schools, tried to figure out is there something I could do. And then later on, when I applied and I joined Shastra University for my PhD, I was so fortunate enough to have a guide who was actually looking into the same area. And that's how we settled that day. And he was a huge advocate of social robotics. That's how we settled that day. It was going to be autism. And thankfully, touchwood, we never turned back. So I did a specialization of robotics for autism in special education. And that's how NIMAYA Robotics was born. There's a lot more story to NIMAYA Robotics. We'll get into that later. So usually when I say that, oh, I develop robotic devices for children with autism, and the first thing they'll be like, why? How does it? Okay, first thing, what is autism? Autism is nothing but a set of complex brain development disorders which poses challenges in social interaction, communication, behavioral issues, and most importantly, daily life activities. I'm sure for us, it's a very, very involuntary process that we do our daily life activities. They find it a huge challenge, right? There are a few myths that I would like to debunk. The reason I'm giving a little bit of autism awareness is I can say probably a bit of a selfishness because as much as we get to know about autism, you can save the next child that you see. And I would really like if the audience are able to get a hint of what autism is and then how our system works. That way, it will wrap the whole thing as a solution for it. And it will help you probably analyze and evolve and probably do this to any other health situation that could save anybody's life. So the few of the myths that I have to debunk is that in India, autism is absolutely prevalent. It is there and it is growing. And they usually say that they don't know what causes it, which is partly true. But the problem lies is basically in the neurodevelopmental disorder of the child. That is in the neural pathways. They say that the therapy cannot work. Therapy absolutely works. There is no cure for autism yet, but you can definitely train them. There is definitely a genetic angle to it, but any child with autism spectrum disorder is very much trainable. So what is it? Most importantly, what you need to understand is the earlier you detect autism, is the earlier you can train the child and the more inclusive the child can become. You can actually have your child from a special school to a normal school as young as possible. Did you know 93 million children around the world have some kind of a disability? 1 in 54 are diagnosed with autism. And that's a huge data for us. So the next question that usually people will ask is, why are you doing robots for autism? How does it work? When I was doing my PhD and I did a little set of literature review, we figured out a ton of different studies have already been done showing that children are attracted towards robot and robot-like features better than human beings. And that's simply because the child can see the robot to be a very inanimate object. Right? An example, say for a mom to ask a child to pick up a glass, the mom is going to say, please pick up the glass the first time. Please pick up the glass the second time. But the third time when it comes around, she's going to be like, would you please pick up the glass? So there is an immediate change in the modulation and the child is not able to associate to it. They're usually okay with the repeated working of it, but then the routine is what that sets them, and that's why they are able to associate with robot and robot-like features more. And that's why we did robots for autism. Surprisingly, there was a ton of different work done in this area. Few of the robots is what you see on the screen, but they were predominantly done for social interaction and communication. As you can see, here the Zeno is basically just for a pure communication. Tito is to show facial expression. So you can see the LEDs here that's smiling and then it frowns. This is to teach the child what a happiness is and what a frown is. Similarly, there are several different robots doing all of that. But then if so many people have already done it, what is that we are going to do in this whole situation, right? So that is when we figured out there was a huge gap in the psychomotor skills part of it. That is, daily life activities is something that has not been concentrated on. Daily life activities comes with a set of psychomotor skills. Daily life activities are nothing but basically us picking up a pen, writing, drinking, holding, brushing, anything is a daily life activity. And it comes with a set of psychomotor skills, right? So what are psychomotor skills? This is very, very important. Your brain tells your body to do something, your body does it, and then it sends back a signal to your brain telling that this action has been carried out. And that's exactly why we are able to coordinate. Now my brain is telling me, move your hands like this. And the moment my hand moves, my brain gets a signal saying the hands have been moved like that. So imagine your brain is telling, go pick up the water bottle. And I am going towards the water bottle. And then I suddenly realize we need to realize this is how we pick up a bottle. But then I suddenly decide to pick up a bottle like this. Is that possible? Absolutely not. Because your brain is clearly telling you what you're supposed to do to pick up a bottle. Has anyone ever thought about once in our entire life how we open and close the door that involuntarily? It's a huge challenge for children with autism. Let alone they don't understand what a door is, but it's very difficult for them to generalize it in everyday life. So imagine all for us is that open a door is a simple action. See the knob, open it. That's not the case. What happens is your brain tells this is the door, you identify it, you reach out for the knob, your shoulder moves, your elbow moves, your wrist moves, your fingers move to the position where you can hold the knob, then you turn it. The brain tells you to do all of this. And every receptor that is there in your skin tells your brain that it works. So what happens with children with autism? Children with autism, the brain is as such, it's fine, and they're physical, they are completely fine. But the neural connectivity between the both is where the problem is. I'll give you a very similar example. You've seen a lot of unfortunate people who ended up being paralyzed after an accident, right? Most of the time, the first thing that the therapist would ask them to do is a physiotherapy. Why do they do that? They do that for months together. They keep moving their hands up and down for months together simply because the repeated you do, the neural pathways, new neural pathways are formed and thus helping you to start moving. That's how amazing our body is. That's why we picked up psychomotor skills and we wanted to figure out how to teach them. So the current therapy system is what you see on the screen. They use different wooden bases. They use like a regular daily life activities and all of that. So you can see these are for different grasps. This is the methodology that they use. So you have a teacher teaches the child the activity. As you can see the arrows, there is nothing back from the activity and the whole thing stops there. Now, the first thing you go tell to an autistic child or pretty much a normal child, go do this. And the first question will be like, why? So for an autistic child, they love their own world. They love what they do, whatever they want to do. So when you go ask them to open a door, the first thought in the child's brain is going to be, what am I going to get out of it? You're opening it for me. So that's completely okay. But that's not how life works, right? So here the teacher teaches the child the activity, and due to the lack of feedback, it takes a lot more duration of time for the child to learn, and much less retention as well. The NIMAYA way is very similar, but with a twist. Here the teacher teaches the child the activity. Now the activity gives you an audio-visual feedback, right? And now what happens is the child is able to understand what the child is doing and is able to relate what the child gets back. This helps the child to not only learn it much faster, but retain it longer and also have it in a very generalized format. This unique concept is called active learning, and that's what each of our devices are designed upon. So these are just to show a simple example of what are the different grasps that's there, right? So we have palmar grasp, we have pincer grasp, and what you see on the screen is what are they used for. Right. That's okay. Moving on. So now what happens? Now we're going to start solving this issue, right? How are we going to solve this issue? What are the grasps that we are going to pick up? What are the skill set that we are going to address? How is it that we are going to work? Based on that, we developed a set of devices. We kind of bifurcated the different sets of cognitive skills and psychomotor skills and motor skills, and then designed and developed a different set of device for each of them. So what you see on the screen are the research prototypes that I did during part of my PhD. Now let me give you a quick run through of what they are. So the robotic device here is to teach them up, down, right, left direction, eye-hand coordination, palmar grasp, etc. And this is an imitation robot. The child has to do whatever the robot does. Here you can see it's almost a mini version of a regular door. Now the child gets to work with the door, understand what a door is, how to open and close the door. Here it's a shoe and a shirt device. I will explain a little more as and when we go further. So, as part of my PhD, I actually developed about 6 different devices. And the final 2 are not on the screen because for IP purposes under patent application, and we are in the process right now. And all of those have been converted into products right now, and 7 more are going to join the family very, very soon. We have one of the quick success story just to show you how the prototype started, how they all turned out to be an IoT device, and how IoT application was used in this area. So the success story is that we used the opening and closing of the door. This door device, we trained a set of children, and these are the skills that we trained. So bilateral coordination is nothing but using both your hands, which is something we normally do. If we hold something in our left hand or our right hand, and somebody gives you something else, we tend to use the other hand to pick it up. But when a child with autism have a favorite hand, just like how we are all right-handed, we are all left-handed, we tend to prefer one hand more than the other, but they also have a favorite hand. But in their case, say they have a favorite hand, their favorite hand is right, and they're holding something in their right hand. Immediately, what happens is that you give them something, they put that down, and they use the same hand. They don't tend to use this hand much at all. So to bring that in, we did bilateral coordination, and we've got high-hand coordination. Palmar grasp is basically how we hold a ball. Wrist rotation is how we rotate a knob, and different set of cognitive skills. So we worked with a set of children in Trichy. We did a set of pre-assessment that is basically to see how the child was before the training and how the child is after the training, right? So we used a real-time door, and then we used a device that could rotate, a contraption that could rotate. So this helps them to figure out if they have wrist rotation or not. And then we have different set of contractions similarly. We did all of this, scored all of them together, then we did our training, and then we had our post-assessment as well. So during the training, we train the children for say about 10 trials per day, right? Over a few number of days. What I did is usually I will teach the occupational therapist. The reason I'm explaining all of you this in detail is I will tell you how it works. So I basically explain the occupational therapist how the system works, and then she trains, I sit and take down the data. Because our most important part in our NIMAYA robotics is that we do parameter-based measurements. Like every single parameter of the child is being followed, which has never been done before. So now I take like a big sheet of paper, several different columns, start writing down everything. Right? If the child is moving the hand, is the assistance given, what side the child is turning, everything is put down. So here you can see in the first graph, the child starts at a score of just a little above 1 for the open activity. And the child is not improving much. Then we've got the close activity where the child is able to do it quite well, but peaks, but then reduces. And then we've got the open and close activity where you can see it is a combination of both, where both has dips, right? But you can progressively see the score keeps increasing. Of course, the score minimum is here 0 if the child does not respond at all, and 4 if the child does it automatically without any kind of assistance. And the number of assistants in between falls under it. So now that was the first 30 trials. And then we went to the last 10 trials, and you can see how the child's minimum score for opening was more than 3.5. And then you could see the child moving above and was able to do it without any kind of assistance. And similarly, that goes the same with the close activity as well. Here, the open activity is using right hand and the close activity using left hand. And that's how it's been represented here. So it's a pretty simple graph showing the improvement of the child over just 40 trials, right? Now, how did this graph come about? I sat and took down every single parameter, put up a score for it, and then mapped it, and then did a set of algorithms. So then we went ahead with the pre-assessment and the post-assessment scores. So again, I had noted down all the pre-assessment, I had noted down all the post-assessment, and then I put up the score against each other, right? And now what happens? You can see The pre-assessment is all the blue and the post-assessment is all the red, and that kind of self-explanatory as to how much the child has improved. In case of subject 4, you can see the child did not have anything in the pre-assessment. The child was able to carry out most of it in the post-assessment, right? This is how we saw the progressive of the child moving. Similarly, we did trials with a lot of children. Towards the end, we figured out this is our average of the first task performance of all the 6 children were for the open was just in the first trial was 45%. At the end, it was 100%. So this was the average of the score that we were able to find. So that's when we figured out, okay, these systems are definitely working because we are able to follow through every different parameter. Right now, what usually the school does is that they do an assessment within 6 months or a year to see if the child does an activity or not. That is, for example, take the door activity itself. Does the child open the door or not? They do not track if the child has palmar grasp, wrist rotation, or how much of a percentage that of the wrist rotation the child has. Sometimes the child is capable of holding it even with the pressure, but just not able to turn. Does not mean the child does not have the grasp at all. So that has not been tracked. So to show you a quick transformation of how our systems work, I'm going to show you a video. Please let me know if you can't hear it.
Hello, ma'am.
Yes. So were you able to see and hear the video?
Hi, yeah, ma'am. Yeah, ma'am.
Perfect. So you could see that uh, the child was very clueless at the start of the training as to what a door was. But just with a few days of training, the child was able to generalize it to any door possible. So I would like you to know that the child was not trained on an actual door. They were only trained in our devices, but was able to generalize it in an actual door. And the most important part was, of course, all of you know how a PhD works, needs a ton of different data. So I had to keep track of every single data that every child went through. To put my entire research in a nutshell is what you see on the screen right now. Worked with more than 60 different children across 5 different organizations, did more than 250 days of work, more than 100 sessions across 6 different devices. Using the data that we got, we realized our systems are 60% more efficient than any regular therapy system that is available in the market right now. But you do imagine the amount of data that comes from it, right? For each child, for each session, there is a 1 page of it, right? And then imagine I'm going to work for 60 different children, more than 100 different sessions. That itself gives you more than 600 different papers. I used to walk around with stacks of them. Now I decide to open a company. Brilliant. That's great. Would love to be an entrepreneur. Would love, most importantly, help these children as much as we could. But imagine me going around with every child and trying to handle so much of data. Or I can't ask a therapist to come and sit and take down, will she teach or will she automatically take down the data? You can't put a two people job for teaching a single child. There are so many different things. That's when the entire solution of IoT helped us in. Right? Now, our entire operations are completely paperless. The therapists don't have to care for anything. Most of our systems, I mean, all of our systems, most of the parameters are taken automatically by the system and sent to the cloud. And the few are entered by the therapist into a device. And that is also goes to the cloud. The algorithm is done there. Now, IoT being with one single solution helped us unimaginably solve most of our problems. Now, for me, scaling or expanding to any other city or a state is not going to be a problem. I don't have to send a stack of data. I don't have to keep track of a data. Nothing. Everything goes there. So how does this work in case of our systems? So we've got a skill training unit. As you can see, this is the overall architecture. So now how I'm going to do for you is that I'm going to map, like I told you, I'm going to explain about sensors, things, gateways. I'm going to map that with my device so that you'll be able to understand. So we have our overall architecture. Skill training unit is where the child comes in contact to learn different type of skills, and there's daily life activities. And then we have the trainer interface unit. It comes with a 7-inch display where the therapists come in touch to enter the everyday data. Now, both of these devices comes with a set of sensors and complementary electronics. Both of these are connected. I2C communication, UART, whichever you want, you choose it. And then both of these put together The data from both of these goes via the Wi-Fi or a GSM module to the cloud application. And we've got our customized application in the cloud, which will basically analyze the different types of data and give you the output. So what makes us best in the market and why we make a huge difference? First, paperless operation. The therapists do not have to worry at all. Since these are IoT based devices, it makes it super easy for not only the children to train, but also for the therapist to use. So we are here to augment the existing therapy. So the regular therapy systems or the therapist will use our devices to make their working more efficient, right? And then so far, 6 different devices alone addresses more than 30 different psychomotor skills. So imagine tracking 30 different psychomotor skills for every child that you train. Right now, what happens? Each of these devices have a dedicated STU. That is the one on the rightmost bottom. But you can't keep sending several TIU and STU pairs to every place. So we've made it such a way that this TIU can connect to any of our STUs and it will automatically figure out how the system works or what system has been connected, which device has been connected. So you can leave one training unit with a therapist in, say, Bhopal, and I can just keep sending the different therapy methods that they require. That one TIU can connect to anything and it works. Of course, like I said before, it is an absolute paperless operation, end to end. It's got absolutely no paper. Now the therapists don't have to worry about what kind of parameters they are following. Everything is taken care by the cloud. And most importantly, you can view all of the results later. So we'll get to that later. So most important is we have parameter-based performance measurement and data tracking capabilities. Now is where we are coming to the detailed version of each of the entity that is part of our systems. Like I told you, to make an IoT solution, we have sensors, we have communication, gateway, things. Of course, cloud. Just give me a second. Excuse me. So what are sensors? Sensors, and I'm sure everybody is aware, sensors are the ones that basically measure any kind of a physical parameter, right? Like for example, temperature, humidity, water level, touch, feel, anything. Most of the time, you have two different sensors, of course, analog and digital. So you need to create a circuit system that can work with both analog and digital. Or depending on the application that you have, create a circuit system that will work with an analog or a digital sensor. It could be ultrasonic, it could be IR, the way you want, program it. Right? Now, for the sensors to work together, you need a microcontroller to read all of this and get it as a data and then send it through. Now we are coming to the things architecture. So, a classic IoT architecture of a thing is what you see on the screen. All the gray areas is the microcontroller part. So microcontroller usually comes with a CPU, a power supply, a memory, a communication protocol, I2C, UART, SPI, anything. Now, these need a set of keys and sensors or interfaces for it to work with, right? So it will probably have different keys that will come in, and then sensors data that comes into the microcontroller, and all of this put together goes through it, and then this all gets communicated to the gateway. And this is how we are going to map it to our devices. Now, what you see on the screen is the actual products that's available in the market right now, right? So what happens here? Each of these devices is a thing. Each of his device is connected to the internet. Each of this acts as a thing. I'm sure you remember the first architecture that I showed you. Thing. Then you have a communication protocol. You have a gateway. Then you have a communication protocol. Then you have the cloud application. So our devices act as a thing. Each of these devices comes with a set of sensors. There are several. For example, if you take the joystick, there are several limit switches. There are several infra IR sensor, and then there is a touch sensor. There's a pressure sensor. There's different things that's there. Similarly, for each of the devices, there are different parameters at once. For example, let's take the door. If you take the door, the parameters that we measure are if the child is holding it right, if the child is turning it, if the child is turning it to the right side, then similarly, if the child is turning it to the left side, and that is mapped to the open or the close of the device, right? Even in fact, there is a small light. I'm not sure if you can see it right now. There's a small light inside the room. So we kind of figure out, we keep a track of that as well. If that one has failed, So when we do it as a product, we need to do for both the children as well as for our own maintenance. So even if the light fails, we'll get to know, right? So what happens is all of these set of sensors keep recording repeated parameters as and when the child keeps working with it. Now comes to the gateway architecture. So as you can see, this is already your microcontroller. All your analog digital sensors are connected. Now you are communicating it to the gateway. Your gateway is where the most important sector of it is, because it may come as a device. It may come requiring an application into the device. For example, in our case, we have a gateway. That's our tablet. I will show it to you in the next slide. That comes with a set of application because this has to get a set of data from the device itself. So gateway can also use as a input here, right? So here the gateway architecture is what you see. This is purely, you can see the hardware here in the bottom. That is our device. The operating system for the gateway is any Android would work. It could be a tablet, it could be a phone, except that you need to have that kind of an application in it, and it will work. And this is the set of stuff that is there in the gateway for you to communicate. And then here it goes to the cloud and you have a custom application there. So this is NIMAYA's gateway. That's our TIU, our trainer interface unit. This comes with a 7-inch display. The one you see here is a 7-inch display. This is where the therapist comes in contact with. It interacts with the therapist in a beautiful user interface unit. So it comes with so the amount of pressure or the amount of assistance that the therapist gives to a child only the therapist can enter, right? So that will be entered by the therapist. And we've made it a super easy GIU where she can just touch and everything is taken inside. So now what happens? You already know that there's set of data coming from the device, set of data coming from the TIU. Now both put together is what will give the child's performance, because the touch, feel, the rotation, how much the child has turned, everything comes from the device. How much assistance that's been given comes from the tablet. Now, what does the tablet do as a gateway, right? From the device, it's already through some kind of a communication protocol. It could be a non-internet protocol, internet protocol, anything is fine. Wireless protocol, it could be Bluetooth, it could be Wi-Fi, it could be I2C, depending on the application. Now that comes to the microcontroller, and the data from here is also stored in the tablet. Now, using our application, this data and the data entered by the therapist goes to the cloud. This Android tablet is the only one that enables it. Android tablet there. How are we going to communicate? It doesn't work. So that is why this is called as the gateway, and that is why this is very, very important for a gateway to be there in an IoT. Okay, so what is the flow that we usually have in an IoT system, right? First, an event happens, right? Whatever happens, there is a change happening that is there in the environment. Some kind of could be analog, it could be digital, that is getting detected. For example, in our case, a child is moving the joystick. That's the event. Now the joystick has a sensor that detects it, right? And now this data goes to the microcontroller. That is where it is getting, like the logging in of it. And now all the data that is stored is getting uploaded to the cloud server. You do a set of analysis there. For those analysis, most importantly, you need to have an application. Again, it's a custom-made application, right? Because your data, you're the only one who knows what to see from that data, what you want to see as a result, what is the outcome you're looking for. You get that data, analyze it, look at the results, then you figure out, you know what? In our case, what happens? We see a child improving. Suddenly, there is a bit of a drop in for the first one, maybe the third week, the child is not doing anything. Though the child already knew the skill, the child is not able to continue it anymore. Then we figure out, okay, something else is wrong. So now we know that we have to call up that therapist and tell her, listen, there has been a lag in this data. Please see if there is some kind of an uncomfortability for a child, is an extra reinforcement is required for a child, or what is that we could change for the child to be more comfortable and actually help them do it. What are the parameters that could be changed? This helps us doing it. Now, over a period of time, this gives us patterns, this gives us every child's improvement, everything. Based on this, we will be able to give it a report to the parents, which would super help. So this is the typical flow. Now you can see we've numbered it for your advantage. So we have the event, that's number 1. 2, is going, that is the sensors or the thing, and then that is getting communicated in the local area network, and then that gets stored in the customized app. In the cloud, the number 5, it goes to the different algorithms in the cloud app. 6, it gives you out the data. 7, you're able to see the progress or the results that you want to see. And this is how the entire typical IoT solution works. So any development is not easy, right? So the magic behind the black box was so much of work that has gone into it, and there is still a lot of work going on. So this just to give you an idea as to how much it will take, what has gone into our devices. So yeah, that's just for an understanding. So we provide not only the device, but we also provide a methodology. We train the therapist to train the children. So this is called a Supra Yoga training. Okay? You can get more details from our website, and I will add it up here anyways. Okay, now we've clearly taught you what an IoT is, how IoT works, what is the requirement and all of it. What is the use of the data that we're going to do? How is it required? Like I told you, for a child, we will know how the child is going to progress, if the child is able to generalize it. Sometimes what happens, we can see the data being so well, but then your parent comes back and tells you, no, he's not doing this in the house. That we can show you a trend showing that, no, listen, the child is able to do all of this. He had a post-assessment here, and where he was able to carry out the same thing. Maybe something else is wrong, please check. Okay. Each of these devices teaches a set of skills. So now the child has a very specific set of concentrated training that happens. Now there is an accelerated improvement. So how did I prove that our systems were 60% more efficient? Because I had our own data when we had control group, target group, figured out our systems work. So data is the one that's going to give you that, right? Now, say if the child has some kind of a issue. Say for example, sometimes the child may not have the touch and feel of a device. Hello?
So one way to do that is obviously the vectorization. So what is the vector representation number 2 qubit? So 1 qubit state has a vector representation. Okay, so I'm going to use a notation here. So when there are 2 qubits, so you can pair.
No, I'm sorry, I'm not able to understand. You're asking me a question. Hello?
I think it's a crosstalk.
Okay. All right. Let's continue. Can you have that person on mute? That'll be helpful. Okay. Sorry about that. So yeah. And now what happens? Say a particular child has a
What is the tensor? The mathematical operation. Tensor of 1 and 1 0 and 1 0 is like a sort of a longer vector the way I have. Another tensor I have is 0 1. So you may have to look up what tensor algebra, what is the tensor later. You want to know a little bit more. How do I? What is the tensor corresponding?
Deepa ma'am, could you mute everyone, ma'am? Dr. Ramya, you need to unmute.
Can you hear me now?
Yeah, you are fine now.
Oh, perfect. Thank you so much.
Yeah, ma'am, we can hear you, ma'am. You carry on, ma'am.
Okay. I think I was talking alone for a while. All right. So now what happens is sometimes a child may not like the touch and feel of a joystick. Say, for example, the joystick top. Now, the child may require a different kind of a top. It may have to be of a different shape, may have to be of a different touch, feel, texture, etc. Now, what happens? Now, what happens is, sorry about that. Now, what happens is that more than one therapist may end up training the child. Now, how is the other therapist supposed to know this child requires this particular contraction to be added? All of these goes as part of the data that you keep. So that way, what happens is you'll be able to tailor make a training program for each child. For the therapist, it's one of the biggest advantages, right? They don't have to take care of the training at all. They don't have to take care of the data at all. They just have to train the child and everything else will be taken care by the system, right? So like I told you, this one TOT can connect, a TIU can connect to any of the STUs that is there, right? And it makes a paperless operation. All they automatically get the progress data, which initially they had to actually sit and work on. And for the parent, what happens is they get the absolute joy of seeing their child grow. They can log into their user ID website anytime. They can figure out which stage the child is in, how much the child has grown, how much the child has progressed from before, what is the next class, what is the next session. Everything can be given to them. So can you see how easy it becomes, more efficient it becomes for the therapist, the parent, and the child? So that is what IoT makes it super easy for people to do, right? So this is just to show from a product to, from a prototype to a product, not much to do. So this is a quote that I always like. Intelligence and capabilities are very subjective. The simplest action may become the best intelligence of tackling an issue at any point in time. So this was by Dr. Prahlad sir. So there are certain things. So when I think I'm going to make it a little more interactive right now. Now that I've given you an idea of what an IoT is, can maybe like 2-3 people come and kind of log in and tell what are the solutions that they think of can work as an IoT? It can be absolutely everyday things. We will quickly start that session. I just would like to thank people who've been a part of it because it's been without their support, there's no way we could have come this far. And thank you. That's the end of my presentation. Hopefully it was very helpful. I would really like if somebody could come up and tell me what are the IoTs they think can work as, or what are everyday life can be made into an IoT solution. Why don't we open to queries with that?
Yeah, ma'am. Good morning, ma'am. My name is Bhaskar Faniram.
Hi.
Ma'am, your session was very interesting, ma'am. And it is very subjective, ma'am. Ma'am, for whatever the question that you have asked, I have one solution, ma'am.
Okay.
Because, see, daily as on our life is going in a very faster way. Daily
Right.
morning we are getting up and we are going to the office, seeing our work and everything. So my solution, how it works with respect to IoT is, if we are going to the office and if there is any power cut in our home and we forgot to switch on our lights, and while the way we are traveling into the office, suddenly it got struck into your mind that there is a power failure and we didn't switch on the switch off the lights. Okay, ma'am.
Right.
So there IoT comes into existence, and by using one app which is installed in our mobile phone, we can control the devices like lights, fans, and air conditioners that are there at home, and we can off the lights such that we can save the power. That is another one important application that I want to suggest that works purely with respect to IoT, ma'am.
Perfect. Yeah, that's great. That's great.
Thank you, ma'am.
And there are a few companies that's working on it right now. Actually, right now I think they've started with like big hospitals and star hotels, and they will eventually come into house markets because right now they're not much of a market for the houses because we just kind of think off and on. But that's definitely a huge IoT solution that can be super helpful in the future, and it's not very far away that we see that. Brilliant. Thank you so much. Is there anybody else who want to chip in and say what they've got?
So any doubts or questions you want to ask that can also be done now?
Yes, please.
So anyone can also post their doubt in the chat box.
I have put my email ID and my phone number in the chat box in case anybody has to reach out to me as well. Okay, we've got Pramod Sahare. Yes, sir. How can we start learning to build application on IoT as a beginner? So since it's kind of a new concept, you can probably start with a couple of basic learner books that does give you a very basic idea of how it can work. Then try to take up like a really small, for example, like how Mr. Bhaskar said, probably see if you can automate a couple of things at your house. Like take two small devices, try connecting that, connect it to a microcontroller, add it to a cloud because we have pretty much everything available. We don't have to go anywhere for a service provider. Everybody has a smartphone, most of us do, and then a Wi-Fi, right? And you can use that. You can use your own cloud space for now. You can use your Drive accounts. There is a possibility. We still do that too. We can do that. And you can start with that and then start going into bigger ones. Let me see if I can share you a couple of books or PDFs that I have that might help you work on IoT. Maybe that will be helpful. I can probably send it through to Deepa ma'am and it can reach you. Will that I hope that works, sir.
Any other questions?
Dr. Ramya, Harikrishnan here.
Oh, yes, Dr. Ayush.
So could you just talk about how the parents felt after the trials? Because that is something which would be which would have made you happy.
Oh yeah, that's huge. Thank you so much for that question. Because one of the biggest reason why we wanted to convert this into a company is one of those things. Because when part of my PhD, when I worked with a lot of different children, and when we were in the start of it, they were wondering if it's going to work or not. That is when I got a call from one of a parent. She called me at 12 in the night, probably in the middle of the night, and she was so ecstatic. She was so happy, and she was like, Ramya, you won't believe what happened. So we actually worked with her son, who was about 4.5, and we worked with them using the imitation robot. The child has mask-like features. The child does not laugh. The child does not have sorrow. The child only screams out of agony, but does not know any other kind of expression. So this is a regular symptom of children with autism. They tend to have very mask-like features. So when the child had gone, after a few days of training with us, the child had gone to a school, and it so happened that there was a child next to him who started crying. So he had come back home and he imitated how the child cried, how the girl cried. And that's the first time in 4.5 years, as a mom, she's actually seen a change of expression on the child's face. So imagine the amazing feel that she would have had. So she immediately called me in the night. She said, Ramya, I have to share it with you. This has been amazing. And that was one of the biggest anecdotes. That was a huge uh, help for us. I mean, it was a huge inspiration for me to get on a move. Similarly, we've had a lot of parents coming and telling us, my child has started picking up stuff in the house and putting it in the basket. We had a child who was able to differentiate between right and left shoes after he started working with us. He started understanding what right is, what left is. In fact, his grandfather used to bring him on a regular TVS 50, and once he told him, can you put the right indicator? And the child switched it on. So these are things that the child had never done for about 7, 8 years so far. So imagine if we could bring in devices like this and change such small things of the life and how it could cumulatively help is I think one of the biggest things that kept me going in this area is the happiness of what the parents come back with and the importance that they say has happened to their child's life. And that's exactly what we are trying to do with NIMAYA. We are trying to reach it to as many children as possible.
So any more questions or queries to the participants? I think we can wind up the session. Thank you so much, Dr. Ramya ma'am, for enlightening us with how to convert from an idea, how we have you have developed to a prototype, and from the prototype how you have developed the product, and then how you went on to start your own company, and in your product how you have incorporated the IoT application and how you have implemented that you had explained to us beautifully. In fact, seeing the work, it looks like a lot of hard work had been put, and it would have taken at least 2 years to develop this product. But you had explained to us in a very easy way in a span of just 1.5 hours. And I would also congratulate you for developing such rare products. So these products are not available usually in many other trademarks. So really happy that such interdisciplinary work has been taken up by young researchers. And you people are in fact a motivation and eye opener for faculty like us, and hope some of our participants will be benefited through this inaugural and introductory session. In fact, I would also like to note that ma'am had given an overview of the gateway in IoT and how the signal flow happens in IoT through her own product. Okay, so that's in fact a very great and positive thing. Thank you once again, Dr. Ramya, and thank you to all the participants for the patient listening. So we will join back again at 2 p.m. So we have the Director of Life Sciences, Virtuosa. He'll be joining at 2 p.m. Request all the participants to please join on time a little bit early so that we show that we faculty are more disciplined. Okay. So thank you so much. Thank you.